Okay, in this video, I want to show you what is an initial value problem. To study initial value problem, first we wanna know what is a differential equation. So here is the definition of a differential equation. An equation which contains the derivative of a function is called a differential equation. So, for example, this equation f prime of x equals 5x to the third. This is a differential equation because in this equation it contains a derivative of a function, and the solution of this differential equation is a function fx. So if we can find what is the formula, what is the equation of the function fx, then that will be the answer, will be the solution to this differential equation. We can see the difference between a differential equation and the equation we have learned before is for those equations we have learned before, the solution are numbers, like here x squared equals 4. The solutions are numbers, but for differential equation the solution is a function. Okay, so to solve a differential equation, we are asked to we want to find what is the family of the antiderivative of f prime of x, right? And to find what is the antiderivative of this function, we can use a power rule. So the answer is 5 over 4 times x to the 4 plus c. So the solution to this differential equation is this. It's fx equals 5 over 4 times x to the 4th plus c. Now here, this solution, we call it a general solution. Why it is a general solution? Because in this solution there is a c which we don't know. We don't know specifically what this number is, because a c represents a constant, but we don't know what specifically this constant is. So that's why it is called a general solution. Now, if we can give an actual information to determine the c, then we will find a particular solution. Okay, and that actual information, we call it an initial condition. So an initial value problem is a problem which we have a differential equation, and we have an initial condition. So we can solve for the particular solution for that differential equation. For example, here we are given this differential equation, and we're given this condition. So this condition tells us for the function fx, when x equals 1, the function value is 3. And the derivative of that function is 3x squared. So we are asked to find what is this function. So which function fx will satisfy these two conditions? One condition is the function value is 3 when x equals 1. The second condition is the derivative of the function is 3x squared. So to solve an initial value problem, we first find what is the family of the antiderivative. So we start by finding what is this. And to find what this is, we can use power rule. So this equals 3 times x squared dx, which is 3 times x to the power of 2 plus 1 over 2 plus 1, which equals x to the third plus c. Okay. Now what we have is only a general solution. Because we still don't know what the C is. And then we can use this initial condition to determine this C. Because it says when x equals 1, the function value is 3. So right now the function is this, right? And since f1 equals 3, then we substitute 1 for x in this equation. We have f1 equals 1 plus c, and this gonna be equal to 3. Therefore, we can determine that c equals 2. So then we can find a particular solution to this problem. The solution is the function f(x) equals x to the third plus 2. Okay, let's verify our result. So if we take the derivative of this function, we can get 3x squared, right? So the second condition is satisfied. And if we when we evaluate the function at 1, the function value is 1 to the third plus 2, which is 3. So the second condition is satisfied. So therefore this is our solution. Okay, let's take a look at some other examples. Alright, so we're given that the derivative of function f(x) is 8 times x to the third minus 5, and the function value equals 4 when x equals 1. So again, we start looking for the antiderivative of the function. We start looking for the antiderivative of function x, 8 times x to the third minus 5. And this equals the integral of 8x to the third minus the integral of 5 dx. And this is 8 times the integral of x to the third minus 5. Again, once we bring the 5 outside, the inside we can write as x to the power of 0 dx. Then we can use a power rule. So we get 8 times x to the 4th over 4 minus 5 times x to the power of 1 over 1 plus c. Okay. Now then, we use this initial condition to determine c. Since f1 equals 4, so f1 equals 2 times 1 minus 4 times 1 plus c equals 4. So c equals c equals 7. Therefore, the solution to this initial value problem is 2x to the 4th minus 5x plus 7. Right. Let's verify this result. The derivative of this function is 8x to the 3rd minus 5. And when the function value equals 1, when x equals 1, the function value is 2 minus 5 plus 7, that is 4. Right. Okay, now sometimes we can have an initial value problem with two initial conditions. Now this is one example. Here we are given that the second derivative of the function is x squared, and the derivative when x is 0, it equals 8, and the function value when x is 0, it equals 4. So we want to figure out what the function f(x) is. Because since we are given the second derivative, so we first need to determine what is the first derivative function. And once we can find the first derivative function, use the first derivative function and use the second initial condition, we can find the f(x), we can find the function. Okay. So to find the first derivative function, since the derivative of the first derivative function gave us the second derivative, right? Therefore, the integral of the second derivative function will give us the first derivative function. So in other words, the antiderivative of the second derivative function is the first derivative function. So we start finding what is the antiderivative of the function x squared. And the antiderivative of x squared is x to the 3rd over 3. Okay. Now this, remember, this is our our first derivative function. Actually, this is a general solution to the first derivative function. Okay, then to figure out what is c, we can use the first initial condition. When x equals 0, the derivative equals 8. So when x equals 0, this equals 8. That means c equals 8. So the derivative function f prime of x will be x to the third over 3 plus 8. Okay. And then to find the function f(x), we consider what is the antiderivative of this function, x to the third over 3 plus 8. So that equals 1/3 of the integral x to the third dx plus 8 times the integral of x to the 0 dx. And that is 1/3 times x to the fourth over 4 plus 8 times x to the power of 1 and plus another constant c1, which is x to the fourth over 12 plus 8x plus c1, and this is f(x). Okay, now to determine c1, we use the second initial condition. Let me write here. Since f of 0 equals 4, then when we substitute 0 for x, this will be equal to 4. Therefore, c1 equals 4. Therefore, the solution is f(x) equals x to the fourth over 12 plus 8x plus 4. Okay, now let's verify this result. Okay, so let's start with the initial condition. When x equals 0, the function value equals 4, right? And the second condition is the derivative equals 8 when x equals 0. So the derivative function, which is x to the third over 3 plus 8. And when x equals 0, this equals 8, right? And the third condition is the second derivative is x squared. So if we take the derivative of this function, we can get 3x squared over 3, which is x squared. Okay, which shows that our answer is correct. Okay, our answer is correct.